Welcome to our YouTube channel. I am G. Chandraprabha from Department of Information Technology, V.V. Vanniya Perumal College for Women, Virudhunagar. Now I am going to explain the topic instruction code in computer organization. What is, before going to studying about instruction code, we are get idea about computer instruction. What is in by computer instruction? A computer instruction is a binary code. What is binary code? A binary code is a group of bits. It specifies the sequence of micro operations for the computer. The instruction codes are stored in memory. Not only instruction codes, these instruction codes are stored along with data in a computer memory. These instructions are one by one fetched from memory and then it will be stored in a control register. After storing the instructions in control registers, the system control, it will be interpreting the instruction and executing the micro operations that are specified by that particular instruction. Every computer has its own instruction set. The ability to store and executing the instructions, each and every computer must be using the stored program concept for this execution. What is in the stored program concept? Under the stored program concept, each and every computer is specialized with, it will be stored in the instruction formats. So instruction code is a group of bits that instructing computer to perform the particular operations that can be performed by a computer. This instruction code is divided into two parts, having its a particular own interpretation. The basic part of this instruction is operation part. The operation part specify what type of operations that instruction can be performed is denoted by this operation part. And then the operation code of the instruction is a group of bits. Already I told this is a this is a binary code. So it will be stored in a group of bits and it will be define the operations. What type of operations that can be performed? It will be performed both arithmetic and logical operations by addition, subtraction, multiplication, which are the arithmetic operations. Shift and complement are the logical operations that can be performed by our computer. The opcode will be helped to perform this type of operations. The number of bits used for representing the operation code. How many number of bits are used for the operation code? It will be basically depends on the how many number of operations that can be performed by the computer, only denoting the number of bits required for the operation. For example, if we have to specify the if our computer has to perform 16 operations, then we need to specify the number of bits to perform the operation is 4 bit. The opcode part specifying the 4-bit operations. 4-bit to representing the each and every opcode in the instruction specify the 4 bits. Then the computer perform the 16 operations. Clear? Okay. The computer which was organized in a single processor register and the instruction code format. That instruction, already I told the instruction code format which has their two parts. The first part specify the operation. The first part specifying the operation, it will be simply denoted by opcode. The second part will specify the address of the operand. What that is the where the operand is stored in the computer memory is represented by this field. Okay. Okay. Next, if you store each instruction word, how many number of bits are allotted for the each instruction code? If the instruction code, if you take the example, if the computer that will be using 4096 word addresses, then the computer need to store the instruction number of bits used by the instruction is 16-bit memory word. So under the 16-bit memory word, the 12 bits are allotted for the address field and the 4 bits are allotted for the opcode field. 0 to 11 bits are used for address and 12 to 15 bits which was representing the opcode field. Here the opcode field is represented by 4 bits. Then you can performing the 16 different operations on this computer. Clear, girls? Okay. Next, this is the structure of the memory. Under this, memory is divided into two parts. It will be storing instruction in a first part and then operands in a second part. The instruction and operands both are be stored in a 16-bit address scheme. It will be following for this computer because you have to storing 4096 words for this in this computer memory. So the control will be reading the 16-bit instruction from the program portion of the memory and also reading this 16-bit operand from the address for operand part of the memory. Next, we see about the register. Each and basic computer system which is having the one single processor register. This processor register is referred as the accumulator. Accumulator is denoted by AC. We need to perform the operations on these accumulator registers are clear accumulator, complement accumulator, shift accumulator. Clear AC means clearing accumulator register, that is clearing the contents from the accumulator registers. Complement AC means it will be find the complement of the operand which was stored in the accumulator register. Increment accumulator register means that will be content of the accumulator register is incremented by 1. So the general processor registers used by our computing system is generally called as the accumulator register. The accumulator register, general purpose registers, which is simply called as the processor register, which will be stored by all our computing system. Okay, clear. Next, what type of addresses that can be used our instruction format? Already I told our instruction format which has in the two fields. One is opcode field, the opcode field that specifying the different operations that can be performed by the computer. And then next field is the address field. The address field which denote the where the address of the operand that be stored in our computer memory is denoted by the address field. The address will be using different type of addresses that can be used our computing system. They will be using the mainly three different addressing schemes are to be used. One is immediate addressing, direct addressing, indirect addressing. What is meant by immediate addressing? The immediate addressing, how to specify this address, these instructions having the immediate address. The second part of the instruction having the operand value itself, then the addressing scheme is denoted as a direct addressing scheme. When the second part of the addressing of the operand is a there is address of the operand is specified for the second part of the instruction, it will be said to have a direct addressing scheme. Clear? Okay, next. What is the third possibility of the addressing scheme is the indirect address. What is in the indirect address? Here the indirect address, the second part of the instruction specifying the address of the memory word of the where the operand is be stored in our computing system is be referred as the indirect address. So immediate address, what is my immediate address? Immediate address, the data itself present in the address field is called an immediate address. Direct address means we can having the address of the operand, it will be in the address field. Third one is the indirect address. Indirect address means this address of the memory word in which the address of the operand is to be stored is a indirect address field. How to designate how this particular instruction belongs to direct memory or indirect memory addressing scheme? It will be denoted by using the one single bit I, the 15th field of this instruction format specifying the whether the addressing scheme is the direct addressing or indirect addressing. When I equal to 0, then the addressing scheme is denoted by direct address. When I equal to 1, it will be denoted as a indirect address. Okay friends, now we can have the clear idea about the computer instruction code. So instruction code is nothing but it is a group of bits that can be used to perform the micro operations on a computer, which is simply referred as the instruction code. Thank you.